In 1977, while the world was busy with politics, music, and daily life, something extraordinary left Earth. A machine, no larger than a small car, was launched into the darkness with a mission so ambitious it sounded almost impossible. That machine was Voyager 1. But this is not just the story of a spacecraft. This is the story of humanity's boldest whisper into the universe. Imagine sending a message so powerful that it travels for decades, so determined that it crosses the boundary of our solar system, not so resilient that even time itself struggles to silence it. Voyager 1 did not simply explore planets, it rewrote our understanding of reality. It ventured past Jupiter, unveiled the mysteries of Saturn, and then did something no creation of Earth had ever done before. It stepped into interstellar space. And now, as its signal grows faint, we stand at the edge of a historic moment. What does its final transmission mean? Is it an ending or something far greater? Tonight, we are not just talking about science, we are talking about courage, legacy, and the unstoppable force of curiosity. Stay with me until the end, because the final signal from Voyager 1 is not just a message from space. It is a message about who we are and who we dare to become. In 1977, Voyager 1 rose from Earth aboard a Titan III rocket, launched by NASA during a rare planetary alignment that occurs only once every 176 years. This alignment allowed a gravity assist trajectory, often called the Grand Tour, using the immense pull of outer planets to slingshot the spacecraft deeper into space without carrying impossible amounts of fuel. The mission was originally designed to study the outer giants of our solar system, focusing on close encounters with Jupiter and Saturn. Engineers equipped the probe with cameras, spectrometers, magnetometers, and cosmic ray detectors, all powered by radioisotope thermoelectric generators that convert heat from decaying plutonium into electricity, enabling operations far from the Sun where solar panels would be useless. Voyager 1's flight path was meticulously calculated to maximize scientific return. After Jupiter, its trajectory was adjusted to pass near Saturn's moon Titan, sacrificing a potential visit to other planets in exchange for critical atmospheric data. The spacecraft was built with redundant systems and a fault protection design, so it could autonomously correct errors, as radio commands take many hours to travel across vast distances. What began as a planetary science mission evolved into humanity's first step toward interstellar space, transforming a finite exploration program into an open-ended journey beyond the heliosphere. The defining triumph of Voyager 1 came during its breathtaking encounters with the gas giants, beginning with Jupiter in 1979. As it approached the colossal world, its cameras transmitted images that transformed textbooks overnight. The Great Red Spot was revealed not as a simple storm, but as a turbulent, centuries-old vortex swirling with unimaginable energy. Voyager 1 discovered active volcanoes erupting on Jupiter's moon Io, the first time volcanic activity was observed beyond Earth, proving that distant moons could be geologically alive. It also detected faint rings around Jupiter, shattering the assumption that only Saturn possessed such structures. When the spacecraft continued onward to Saturn in 1980, it delivered equally revolutionary insights. Its instruments mapped the intricate braiding and gaps within Saturn's rings, revealing gravitational interactions with small moons that sculpted their delicate architecture. One of the mission's most significant decisions was a close flyby of Titan, Saturn's largest moon. Data confirmed a thick, nitrogen-rich atmosphere, sparking decades of speculation about prebiotic chemistry and the potential ingredients for life. That choice altered Voyager 1's trajectory, sending it upward and out of the plane of the solar system, ending any chance of visiting Uranus or Neptune, but ensuring an unparalleled study of Titan. These planetary encounters were not mere snapshots. They rewrote planetary science, demonstrated the power of gravity assists, and proved that robotic explorers could act as humanity's distant senses, extending discovery far beyond Earth's reach. Among the most profound elements of Voyager 1 is the inclusion of the Voyager Golden Record, a 12-inch gold-plated copper phonograph record attached to its frame. Conceived as a time capsule for the cosmos, the record was curated by a committee led by astronomer Carl Sagan. Its purpose was not scientific measurement, but cultural expression, an attempt to represent the diversity of life and thought on Earth to any intelligence that might one day encounter it. Encoded on the disk are 116 images depicting human anatomy, mathematical definitions, planetary diagrams, and scenes of daily life. It also carries natural sounds: wind, thunder, ocean waves, birdsong, even the rhythmic pulse of a human heartbeat. The record includes greetings spoken in 55 languages, offering simple messages of peace and goodwill. Its musical selections span continents and centuries, from Bach and Beethoven to traditional songs from Asia, Africa, and the Americas. Detailed instructions for playback are etched onto the aluminum cover, along with a map of pulsars designed to indicate the Sun's location in the galaxy. The Golden Record transforms Voyager 1 from a machine of exploration into an ambassador of Earth, a silent envoy carrying fragments of human identity beyond the Sun's protective boundary. Long after its instruments fall silent, the record will endure for billions of years, orbiting the Milky Way as a testament to humanity's desire not only to explore the universe, but to introduce itself to it. In 2012, Voyager 1 achieved a milestone no other human-made object had reached. It crossed the heliopause, the outer boundary of the heliosphere where the Sun's solar wind is finally overtaken by the pressure of interstellar space. The heliosphere can be imagined as a vast magnetic bubble inflated by charged particles streaming outward from the Sun at supersonic speeds. For decades, scientists debated where this boundary truly lay and how it would be detected. Voyager 1 carried instruments capable of measuring changes in plasma density, magnetic fields, and cosmic ray intensity, allowing researchers to identify the transition not by a visible line, but by subtle shifts in energetic particles. As the spacecraft approached the edge, its detectors recorded a dramatic drop in solar origin particles and a sharp rise in high-energy cosmic rays from beyond the solar system. Plasma wave measurements confirmed a denser medium consistent with interstellar space. Although the magnetic field direction did not change as dramatically as expected, the combined data provided compelling evidence that Voyager 1 had entered a new environment entirely. This crossing marked humanity's first direct sampling of material originating from distant stars, effectively extending our physical presence beyond the Sun's influence. The event transformed Voyager 1 from a planetary explorer into an interstellar probe, carrying our instruments into a region once accessible only through theory and distant observation, redefining the boundary between our solar neighborhood and the wider galaxy. Today, Voyager 1 is more than 24 billion kilometers from Earth, making it the most distant human-made object ever created. At that unimaginable distance, a radio signal traveling at the speed of light takes over 22 hours to reach it, and another 22 hours for a reply to return. Communication is not a conversation, but a patient exchange across nearly 2 days. The spacecraft's survival depends on 3 radioisotope thermoelectric generators that convert the heat from decaying plutonium-238 into electricity. However, this power supply diminishes by about 4 watts each year, forcing engineers to make difficult decisions about which instruments to keep active and which to shut down permanently. Over time, heaters have been turned off, backup systems retired, and scientific instruments powered down to conserve energy. Each shutdown is irreversible, a reminder that Voyager 1 operates on borrowed time. Yet, despite its age and the harsh conditions of interstellar space, it continues to send back valuable data about cosmic rays, magnetic fields, and plasma waves. Engineers at NASA's Jet Propulsion Laboratory have even revived thrusters long thought unusable, demonstrating remarkable ingenuity in extending the mission's life. The extreme distance also means the spacecraft's signal is extraordinarily faint, requiring the vast antennas of the deep space network to detect its whisper against cosmic background noise. Every transmission received is a triumph of precision, patience, and persistence, as humanity listens carefully to a machine operating at the very frontier of interstellar darkness. The idea of a final signal from Voyager 1 is not about catastrophe but inevitability. Its power source, steadily declining since 1977, will eventually drop below the threshold needed to operate its transmitter. One by one, instruments have already gone silent, not because they failed, but because engineers deliberately powered them down to extend the mission. At some point in the coming years, there will not be enough electricity left to run even the communication system. The spacecraft will continue drifting through interstellar space, but Earth will no longer hear its voice. That final transmission will represent the outermost reach of human communication, a moment when the expanding sphere of our technological influence pauses at a defined radius. Yet the significance runs deeper than engineering limits. Voyager 1 embodies the principle that exploration is an act of faith in the future. When it was launched, no one alive today knew whether it would survive long enough to leave the heliosphere, yet it did. The final signal will not erase its achievements, it will crystallize them. The spacecraft will remain a silent traveler, carrying the golden record and the imprint of our scientific ambition for millions of years as it orbits the center of the Milky Way. The loss of contact will be a reminder that while machines have lifespans, the impulse that created them, the desire to understand, to reach outward, to leave a trace in the cosmos, endures beyond any single signal. As we reflect on the journey of Voyager 1, we are not simply telling the story of a spacecraft. We are witnessing the story of humanity at its boldest. From its launch by NASA in 1977, to its breathtaking encounters with Jupiter and Saturn, to its historic crossing into interstellar space, Voyager 1 has become a symbol of courage wrapped in circuitry. It carried not only scientific instruments, but our curiosity, our culture, and our hope. Every signal it sent back across billions of kilometers proved that distance cannot silence determination. And when its final transmission eventually fades into cosmic quiet, it will not mark the end of exploration. It will mark the beginning of legacy. Voyager 1 will continue drifting among the stars, a silent ambassador carrying the golden record, a reminder that on a small blue planet, a species once dared to reach beyond its limits. To everyone listening, may this story ignite something powerful within you. May it remind you that even the faintest signal can travel extraordinary distances when fueled by purpose. Keep exploring, keep questioning, keep reaching for horizons that seem impossibly far. Good luck in your journey, whatever stars you are chasing. And thank you for listening, for believing in discovery, and for being part of a generation that still looks up at the night sky with wonder.